So hello, hello, hello. Welcome to the Smooth Brain Society. So you know that moment when a toddler just loses it, can't help themselves, grabs the things you said not to grab, melts down in the supermarket. Yeah. Well, what if I told you that their brain is literally learning how not to do that in real time? Well, today to explain that further, we're talking to Dr. Abigail Fiske from Lancaster University, a neuroscientist who literally puts light sensitive caps on babies' heads to watch their brains while they're learning self-control. She's been tracking the same kids from 10 months old all the way through early childhood, even managing to keep up with it during the pandemic, mapping what happens in their prefrontal cortex while they're learning inhibitory control. Abigail completed her DPhil in experimental psychology at Oxford, and her work was recognised with the British Psychological Society's Award for Outstanding Doctoral Research in 2024. Whoop, whoop. Her research combines developmental psychology and cognitive neuroscience to understand how executive functions actually develop in those critical early years, not in theory, but by measuring real babies' brains as they learn and grow. Welcome, Abigail.
Hi, thank you so much for that intro. It was amazing.
Good. Excellent. I'm glad you. Well, thank you for joining. It is lovely to have you here.
Yeah, looking forward to it.
So if we're happy to just go,
Yes.
should we start with I love this question, your origin story. How did it all come about to where you are today?
My origin story. Well, I don't think Marvel are going to make a film about this.
Mm.
But I guess I can kind of start off. Yeah, so before I started my career in kind of research and academia, I actually had a career as a primary school teacher. So when I finished my undergraduate degree, which was in psychology, I actually trained as a primary school teacher and worked as a primary school teacher for 4 years, and had some amazing experiences in the classroom. Loved working with children of all ages. But it was actually in the classroom that I started to really pay attention to these kind of executive function skills, which I'm now researching. And it was in the classroom where I kind of noticed the differences in the children that I was working with. And I was very curious about understanding more about the role that these skills play in the classroom. And so I was thinking, actually, I want to go back to university and I want to understand more about this. So I was able to find a master's program, which allowed me to kind of explore this a little bit in more detail. And then eventually that led to my PhD at the University of Oxford, where I kind of went to the other end of the spectrum. And so instead of working with primary school age children, went right to the very start of life, working with infants to try and understand, okay, we know these skills are super important in the classroom. I've seen that for myself, but actually, where do they emerge? How do they develop? And how do we get to that point where children are in the primary school classroom?
Mm. So that's fun. So you did it instead of like, most kind of academics, they go straight from the BSc to the master's to the PhD. You kind of were like, nope, I'm going to get, all this kind of like actual understanding of what's going on in the classrooms and what about the children instead of the kind of the academic kind of like understanding first, which is actually probably better to understand actually what's the kind of the problem or like the target, and then kind of learning how am I going to learn more about that. Oh, I love that.
Definitely. Yeah, it really kind of grounded my research now, right? Because I kind of always go back to actually what this looked like in my day-to-day life as a teacher and in the day-to-day experiences of the children in the classroom. And so it kind of just puts this extra layer of meaning into what I'm doing because I have that experience of why this is actually important in real life. So yeah, that's been really cool.
Yeah, excellent. So what would you say those early years in the classroom, and what do they teach you about child development that maybe the textbooks didn't, or maybe what, a lot of academics don't get? It's okay. We can say that.
What a great question. So one of the main things I think is that you can't get from a textbook is just how when we consider an aspect of development as researchers, that is our world. We are just focusing on that one particular skill or area of development, and we maybe tend to ignore what's happening around that skill and actually forget sometimes that this is a little person. This is a child who's having, a life in the world, and beyond the thing that we're interested in, actually they're also developing their social skills and their language skills and their ability to catch a ball, and they have family relationships. And I think being in the classroom really kind of put that into, something you can't ignore, because these children come in every day and they tell stories about things that have been happening, and we see these other skills develop. It isn't just happening in isolation for the thing that we're interested in, but often that is how we tend to study it. So yeah, it's been really interesting to kind of keep that at the focus. Actually, this is a child who has lots of things beyond the skill that we're looking at.
So, okay, so background, completely understand, child development. What's made you specifically start to look at executive function development with your supervisors?
Yeah, so executive functions are cognitive skills that we know are really, really important for learning. And they are skills that we see every day in the classroom that are very obvious and cannot be ignored. So things like the ability to listen and follow instructions, the ability to ignore distractors, which are everywhere in a classroom environment, the ability to kind of remember the rule that you need to follow for a specific task, and then actually how to change that when you're moving your attention onto a different kind of task. So all of these skills are so present in the classroom, and essential skills for learning. So it kind of made sense for me, coming from that kind of education background, to understand what, when we go back, what these skills look like in infancy and toddlerhood, and actually try and figure out how they get from their sort of very rudimentary basic skills to these really complicated, sophisticated skills that the children need in the classroom.
That's so cool. So I guess my first question would be then, how do you look at these skills? I feel how do you study a infant? It's not like they can talk at this point, so you can't really like ask or judge them. I know you can see the growth of their language skills, but what are the sort of techniques you use to actually study these?
Yeah, so that's a big question. And the very short answer to that is it is very difficult to study these skills in infants and toddlers, because of the reasons you just suggested, right? So children of this age don't yet have language skills, so we can't sort of ask and answer questions with them. And also, they are still very much developing their memory capacity. So when we are thinking about how to measure skills like memory, attention, impulse control, we're really restricted in what we can do, right? Because these young children can't follow instructions to complete a task, for example, which is something we might do if we were working with maybe school-age children. We could give them a set of instructions about how to complete an activity, and that would be able to measure their executive function skills. But that's not going to work with babies and toddlers, right? So one of the biggest challenges actually in the field that I work in is this lack of methodology and lack of tasks that we can use to assess early executive function skills. A lot of progress has happened in terms of researchers being really creative to develop tasks that are suitable for infants and toddlers who aren't yet able to talk. And we've made really good use of technology to help us to do that. So a common method that's used in developmental psychology is eye tracking. And eye tracking is where the infant would not need any instructions. They would be able to look at something happening on a screen, and what we present them would be carefully designed to kind of assess their ability to maybe remember the location of a toy that they were just shown, for example. And the eye tracking would essentially follow their eye movement around the screen, and from that we can make inferences about their understanding and their behaviour. And that, so as I suggested, that doesn't involve any sort of need for communication. We also have, or my supervisor, Dr. Carla Holmberg, has developed a really cool iPad task that has allowed us to measure inhibitory control from infants actually as young as 10 months of age, and actually is a task that can be used with all ages across the lifespan.
Sorry, can I just pause very quickly and ask you what inhibitory control is?
Sure. Yeah, so I guess I've kind of used a couple of phrases so far that maybe thinking about inhibitory control. So the first thing I said was, in the classroom, I said about ignoring distractors. And then I also said about impulse control. So inhibitory control, kind of the definition that I work with for inhibitory control is the ability to kind of stop or prevent yourself from acting on habit or an impulse. So we think sometimes of examples like driving. So imagine you're somebody who drives a manual car. You're very used to going for a gear stick to change gear when you come to a junction, for example. But imagine your car is in the workshop and you have a hire car for the day and it's an automatic car. Now, when you approach a junction, you might automatically reach for a gear stick that you don't need because you're in an automatic car. And so actually, you've got that habitual response, which is reaching for the gear stick. But now in this situation, that's no longer required to meet your goal. So it would be necessary to kind of inhibit that response in order to then achieve your goal of maneuvering at the junction or whatever. So in infants, we obviously measure that in a very different way, but kind of still the same underlying idea that we're asking them to inhibit an impulsive response or an automatic response. And so the iPad task that Dr. Carla Hombo created is measuring exactly that. It's measuring children's ability to overcome a response that we've sort of trained them in. So the basics of this is that infants see two blue kind of buttons either side of a iPad, and one of them has a smiley face. And we teach them that when they touch the smiley face, a little cartoon animation appears with some music. It's really sweet. So they're very quickly able to pick up on this kind of stimulus response idea that when I touch the smiley face, I see a little cartoon. So that happens on the same side of the screen for the majority of the trials. But then to assess their ability to kind of overcome or inhibit that response, on 25% of the trials, we put the smiley face on the opposite side of the screen. So now babies are really well practiced at responding on this side of the screen, for example, but all of a sudden the smiley face is on the opposite side. And so what they need to do, if they can, is to stop that response, the automatic response to one side of the screen, inhibit that, and then actually make the alternative response on the opposite side of the screen in order to see the smiley face. And we find that infants are able to do this task really well. They're able to access the task and complete the task, but their inhibitory control abilities are very poor, as we would expect. So yeah, creativity in the way in which we assess these skills with very young children.
I guess the follow-up question would be, at what age sort of do you start seeing this inhibitory control on that iPad task improve? Yeah, because I feel brains develop in kids really quickly.
Yeah, exactly. So we've measured this task now, we've used this task now, to measure inhibitory control, as I said, from 10-month-olds all the way through kind of toddlerhood, early childhood, and it actually can be used with adults too. And it's around sort of the toddlerhood years that we start to see improvement in this task. So in my PhD research, I followed the same group of children, and it was when they reached 3.5 years of age that we started to see pretty high accuracy in terms of their inhibition. They were much better able to prevent themselves from making that automatic response. But interestingly, they were much slower when they had to respond to the opposite side. So there's this kind of speed accuracy trade-off that happens in early childhood that allows them to be successful in inhibiting, but actually it takes a little bit longer for the brain to put that stopping kind of thing in place.
I mean, to be fair, going back to your car example, even in adulthood, it takes a while to get used to certain things. For example, I was just in Iceland and they drive on the other side of the road to the UK. And the first 20 minutes of me having a car there, like trying to inhibit all my natural instincts of taking a left instead of taking a right. And
Right.
so on. So
Exactly.
I understand the plight of a 3-year-old having to press a
It
screen.
happens all the time in real life, right? As adults, like, I don't know, if you move something in your kitchen cabinet from one side to the other, like you will still instinctively go to the where it was previously, even though you know that you've moved it to the other side of the kitchen. But your brain kind of is just a little bit slower at remembering because we've made quite a strong connection to that particular place. So, yeah, it kind of does take us, even as adults, some time to relearn those things. So when we ask young children to do this, we have to expect that yeah, it's going to still be very, very difficult.
Is there like I guess, because I know you've only gone up to like 3.5 years, is there like a kind of peak age where, impulse control, we're particularly good at impulse control?
So that's a good question. And I know that, so I don't do research with adolescents, but I know that in adolescence, we start to see some more challenges with impulse control again, or some differences in impulse control, which is really interesting because it's sort of similar to what we might expect, or what we might experience in toddlerhood, right? Where young children are still having difficulties with impulse control or inhibitory control. Um, because of the development, and I'm sure we'll talk about this later, but because of the development that's happening in their brain. And then you compare that to a period again of huge brain changing in adolescence, and we again start to see those really interesting differences in inhibitory control. And that follows through actually then to another period in life of kind of older adults and aging, where we again start to see slowing in things like inhibitory control. So it's a really interesting kind of like lifespan trajectory. And I don't know exactly when the kind of peak of inhibitory control development is, but it's interesting to think about those periods of change.
It feels like when the brain is at its most stable, isn't it? So those stable-ish periods, I guess, are like late 20s, early 30s, maybe for a little bit, and then uh,
The master decline. No, I'm joking. There's no master decline. Please don't worry, people. So yeah, so you've kind of like explained the executive control and in toddlers, but I guess the big question, and I know that this will be your first thought when you do these things, is why does this matter? So executive function in early childhood, is it linked to all sorts of outcomes in life, for example? Why research it?
Yeah, that's a great question. And it's one of these things that you kind of can ask anybody about their research. Why, like, why, why should we care? What does this matter? But one of the things I think that's so great about studying executive functions is really, like, it is clear to see how important they are. So I've already talked a little bit about coming from the classroom and understanding how important executive functions are for learning in the classroom. And researchers suggested that executive function skills are quite clearly associated with skills like early mathematics, early language skills, and even scientific kind of inquiry and those sorts of skills too. We know that executive function skills do continue to have an effect on kind of academic achievement and things like sort of secondary school assessments and throughout. And there's also been some really meaningful, I think, longitudinal research that suggested that kind of children's self-control in those early years can go on to predict things even like their health, their mental well-being, their financial outcomes, things like criminality and substance misuse in adulthood. And so those kinds of findings are really significant, and kind of put things in perspective when I'm looking at these skills as they emerge, to think actually these are going to have significant importance for children at every stage of their life. Um, and even if it was just something that was important for education, right, I think that would still be very meaningful to be able to understand, okay, what is it that underlies learning that children will need throughout their education career, and how can we understand this better, and is there anything we can do to support the development of these skills?
Yeah. You've but literally just started on the next question, but I guess this is probably the next part of the research, which is what can you do to have better self-control when you're a toddler, if that's something so important. But it sounds like
I
early days on that.
All the toddlers out there are asking this exact question.
Knew it. Knew it. All the toddlers out there listening, listen up.
No, that's a really great question. And one of the things we are sort of trying to understand in this research is what is supporting this kind of self-control or executive control development in toddlerhood. And we know, as I said, that toddlers aren't very good at doing this. They rely very heavily at this age on kind of experience and the responses that they get during those experiences. So having the opportunity to practice self-control or being sort of challenged in situations by parents or caregivers that maybe you need to practice self-control is the best way for young children to learn. So not only are they going to have the experience and kind of understand what it feels like when you need to have self-control or inhibit a response, you're also going to learn from how the caregivers and parents around you respond to that. So whether they're sort of able to support you and give you encouragement about, if you can wait for this now, you're going to have a really exciting treat later. You learn techniques like distraction, and that often comes from parents, right? If toddlers or young children are sort of desperately asking for something, but they need to wait, parents are very good at playing little games or just telling stories and things that sort of take the child's mind off of it, to enable them to kind of cope with the difficult sensation, right, of having to wait for something. And it's funny because you might have seen online on social media and stuff, parents doing these kinds of challenges with their toddlers, right, where they set up like their phone recording and they put something like a cake or something really nice, in front of the toddler. And they sort of say, I'm just going to go and get something. Don't eat it yet. Or if you wait until I come back, you can have another one, or and then they, of course, leave the room and they've set up the video recording and you can see how the toddlers respond to that. And that's actually, it's very amusing to watch, but actually it's very similar to one of the tasks we use in the lab. And what we're doing during those, that period of waiting is looking at the strategies that children choose to use to help them with that wait time. Of course, some children won't have any strategies. The temptation may be too strong and they can't resist, but some children will show other strategies that maybe they've learned. So things like physically turning away so you can't see whatever it is, the cake or whatever. Some children may distract themselves by singing or telling a story or whatever it might be. And it's really fascinating to kind of observe those behaviors. And I think one of the ways, we can support young children during that kind of learning of self-control is to give them the opportunity to practice and demonstrate kind of some skills and strategies they can use to help with that.
Yeah, that's
Am I
really
making this up?
I was going to say, was it Diamond et al., the study that did the self-control with children study, I think. So it's actually been scientifically as well as the parents doing it. I think Haribo did an advert probably as well.
So this is a really famous kind of experimental setup. It came from the marshmallow test.
Yes, that's what I was thinking
which
of.
came out of, I think, Stanford University in like the 70s or something. And lots of researchers have kind of adapted this task in many different ways throughout this kind of time. And there's been really fascinating studies that have shown like children's behavior on that exact kind of task can predict lifelong outcomes in terms of their executive function skills. So really fascinating, actually.
Yeah, it is. It's I mean, I always love it when things like scientific research kind of passes over to something so that everybody can do it and can see the outcomes. It's fun. It's a lot of fun.
It is fun. And it's great for me to see these on Instagram when they come up because I'm like, oh, what's that child doing as their strategy? But yeah, exactly. This is a sort of task that we've included in my own research where we gave children a sort of, we told them that we had a gift for them and it was in this beautiful gold bag. But we had to say, oh no, I've forgotten the shiny gift bow that goes with it. So I'm just going to go and find it, but I'll leave the gift here, try not to touch it until we come back. And we have sort of cameras rigged up in the room and everything. And we leave the child for 3 minutes which feels like an eternity. And of course, we look for the behaviors that the child shows towards that, whether they're sort of peeking in, whether they've gone and taken the toy, what they do towards it. So one of our studies, has sort of looked at the behaviors that are shown, and we kind of make this, we have this coding scheme that allows us to kind of track what strategies children are using, and we can use that then to predict their kind of scores on other executive function tasks as well. So it's really, really interesting.
So kind of moving on how, because I appreciate this kind of like you look at the children, how they do it. I'm also, you've done some stuff with functional near infrared spectroscopy. We'll call it FNIRS from now on.
Yes.
How does that link in with what you've done? And also, what is FNIRS as well?
Firstly, well done on your pronunciation. FNIRS, yes. So FNIRS is a relatively new technology. It's been sort of used now for about 20-25 years. But it's a infant and child friendly neuroimaging technique that allows us to essentially understand a little bit more about what regions of the children's brain are sort of active during specific tasks. And the way it works is that it uses near infrared light, which is completely safe and part of the sort of spectrum of light, and it shines into the child's head. And basically, the way that the light comes back to the detector on the hat allows us to understand which parts of the brain are busy consuming oxygen. And if they're busy consuming oxygen, we can kind of infer that means they are sort of involved in whatever it is that the child is doing. So essentially, they just wear like a little swimming hat that has lots of sensors attached to it. It's quite comfortable, and takes a lot of effort and a lot of practice to be able to get it onto a wriggly toddler's head. But once it's on, they're usually pretty happy with it, and we can then use the FNIRS kit to understand a bit more about what's happening in the brain, for example, when children are completing an inhibitory control task. So we talked a little bit at the beginning about like how do we measure these skills in this age group, and so FNIRS is another tool that we have that's been really valuable to help us really provide that missing piece of understanding that we need when we think about development over this period. So we've been able to find ways to measure behavior, and we've talked about some of them, but to be able to understand what's happening in the brain during that behavior, but also longitudinally over time. So as we mentioned, my research follows the same children across different age points. So when we can compare, okay, what was the brain doing during this task when they were 10 months old to what's the brain doing now that they are 16-month old and completing the same task, we can start to see kind of how the brain and behavior are related and what's maybe driving improvement in these skills over time.
So the next question would be, what have you like kind of found when you sort of do this with a 10-month-old versus a 16-month-old?
Yeah, so this is really quite fascinating. So I should say that when I was doing this research for my PhD, we really didn't have any information about what's happening in young infants' brains during inhibitory control tasks because it's so difficult to measure. So when we started this, we didn't really know what we were going to find. We had some ideas based on research that's used other techniques such as EEG or research with adults. But we didn't know what we would expect with infants. And what we found when the infants were 10 months of age was that when they were trying to inhibit their responses, we saw areas of the prefrontal cortex, particularly on the right side of the prefrontal cortex, as well as areas of the parietal cortex, again, just on the right-hand side, were working hard during that period. We were really excited about that because those areas, so the prefrontal cortex and the parietal cortex, particularly the right side, have been found in adults. So when we saw it already at 10 months, we were like, yes, we're seeing something here that could be meaningful about how inhibitory control develops. So we know that the 10-month-olds weren't really very good at inhibiting, but we saw this activation. When the children came back at 16 months, they completed again the same task with the FNIRS kit. And here we saw that they were no better at 16 months than they were at 10 months. So behaviorally, they weren't able to demonstrate any improvement in their inhibitory control skills, which was fascinating. We weren't expecting that. We thought there might be some improvement. But what we weren't expecting and what was really interesting is that at 16 months, we saw some real differences in the areas of the brain that were being used when children were trying to inhibit. So now we saw activation on both sides of the brain, again in the prefrontal cortex, but now we saw some areas involved that we hadn't seen previously. So now we start to see involvement of the right inferior frontal gyrus, which is a key kind of indicator of inhibitory control in adults. And we also saw involvement of the left parietal cortex as well. So essentially, whilst at 10 months we were seeing brain activity just on the right-hand side, at 16 months, despite there being no change in performance, children were now recruiting both sides of the brain and actually a sort of more diverse region of the brain. So that was really fascinating, because if we'd have just done this behaviorally, we wouldn't have really had a story to tell. Well, we would have had a story to tell, but we wouldn't have been able to sort of understand what that meant. So what we kind of conclude from that is that there's significant maturation that's happening in the brain from 10 to 16 months. And some of that involves this wider recruitment of brain areas to support inhibition, but behaviorally that hasn't quite come through yet as having improved. So that was really super fascinating. Yeah.
I guess then by the age of like 2 years or something, would you then see all these areas which are being used kind of show up in behavioral differences as well? Then have you done FNIRS with older toddlers as well, or?
So this is exactly my key question. And as was mentioned earlier, this research was happening during the pandemic. Well, kind of either side of the pandemic. And so the intention of the study was that we would continue following these children when they were 2 years old and 2.5 years old, exactly to answer the questions you just raised. But because of the pandemic, the study was hugely disrupted. And so we couldn't test those children at that age. And the nature of longitudinal work with kids is that those kids are going to keep getting older. They aren't going to stop just in time for the study. So we actually don't have the data from 2 and 2.5, but what we do have is data from these children when they're 3.5. And that was because sort of with the timing of the pandemic, I really wanted to catch the children again before they started school, which happens around 4 years of age. So luckily we were able to see them again at 3.5. Now, of course, there's a huge difference in time from 16 months to 3.5 years, and so substantial development, right? So as we would have expected, the children now at 3.5 are much more accurate when they're asked to inhibit. They're much better at it. We would expect that. But we're now seeing in the brain that the activation goes back to the right hemisphere. And that's really fascinating, because research in adults, again, seems to suggest that the right hemisphere is quite important in terms of the frontal and the parietal cortex in inhibitory control. So we have an incomplete picture, right, at least from my research, but it may suggest that by 3.5, we're starting to see a more adult-like kind of recruitment of these brain regions, whereas maybe in toddlerhood, from 16 months where we see this kind of bilateral involvement, I might suspect that we continue to see that in toddlerhood, and at some point there will be this shift back to sort of the more mature, right localized activation. But this is a question that I'm hoping to conduct more research to actually, find out.
Yeah, that's so interesting. So it seems like he's saying, kind of from what I could tell, from when they're about 16 months, there is recruitment of lots of different regions. Looking at the white matter pathways would be fascinating. And then and then later on it goes just back down just to those kind of like right hemispheres. So it's almost like pruning back almost, do you think?
Back,
Yeah, yeah.
exactly. Yeah, it's like specialization of that kind of network, which is fascinating. Yeah, it's just so frustrating that kind of the answers of how we get to that point are kind of in that missing period of missing data.
Yeah.
So my future research is like, I need those toddlers. I need to get those toddlers, and I need to see what happens in their brains to hopefully fill in this picture.
I'm also thinking about, because we mentioned adolescence as another time where sort of inhibitory control is sort of impacted and there's times of heaps of changes. Would you see similar sort of activity then, or are they for completely different reasons?
Yeah, this is an incredibly interesting question, and I don't know the answer to that, but I think it's a good hypothesis, right? Like that we would expect this period of change in the brain of with adolescents for there to be maybe some differences or change when we're thinking about inhibitory control. But what direction that goes in, or what specific regions of the brain are implicated, I mean, I would suggest there would be differences in the prefrontal cortex, right? Because we know those areas of the brain are really important for these higher level cognitive skills, planning and organizing, all of this sort of executive skills, impulse control. So we would expect maybe that there would be some changes here. But this is my focus of research is sort of really on the early years of life. So I probably need to find a friend who can work with teenagers, and I'll deal with the toddlers.
I have another kind of speculative question, which is to do with children who show sort of neurodivergent tendencies, and like infants and toddlers who show it. I do not know, I'm not a clinician, how young you can diagnose these things or these tendencies are shown, but did those also come up in terms of inhibitory control and how brain regions activate in terms of, yeah, FNIRS and things?
Yeah, so again, that's such a great question. And it's something that kind of forms a bigger perspective in terms of my research. So we know that in neurodevelopmental disorders such as autism spectrum disorder or ADHD, that it's quite common that there is some sort of executive kind of differences. ADHD, there's often difficulties with kind of impulse control stuff. But there can also be in some strengths in other areas that you might think are a little bit different than sort of the typical trajectory. So it's really fascinating, the kind of executive function profile of children or adults with autism and ADHD. It's often the case that kind of formal diagnoses for these kinds of conditions don't happen until well into primary school, which is again kind of another sort of motivation for my research, is that having been in the primary school, seeing some of these differences and difficulties in executive functions play out, and potentially these having kind of neurodiversity aspects, it makes me think, okay, well, at what point in development can we start to identify perhaps children who either may later go on to develop or be diagnosed, with neurodevelopmental differences, or is it the case that there are children who sort of may deviate from a typical trajectory but could later catch up? And so it's one of the questions that's quite important for me in my research, is to understand kind of before the child walks into the primary school classroom at age 4, is there a way that we can identify children who may need that little bit of extra support in preschool or in the home that actually then allows them to start at age 4 with sort of a strength, rather than waiting until they're sort of 8 or 9 to go on and be, suggested that they need support or have difficulties. Some of the research that, not that I've done, but that other people have done with infants and young children, is to ask for participants from families who have a history of autism or ADHD in the family, because we know that sort of that sometimes has an increased likelihood that the child may then experience similar things. So that kind of research has suggested that if you have a family history, a family connection of autism or ADHD, we might then be able to sort of see whether those traits or those differences come forward in infancy and toddlerhood compared to a sample of children who don't have that same history. And so that kind of puts us in a position where we might be able to say, okay, this is what typical toddlerhood development looks like, bearing in mind that that's going to be very different for each child, but we can sort of say typically where we might expect to see improvements, and then be able to start to identify, okay, which children maybe fall away from that trajectory, and having the power of kind of the FNIRS to help us with that. And as I said in my results, we saw changes in the brain before we saw it in behaviour. So having that additional tool might be able to give us some answers sort of earlier than we might be able to do otherwise. And I think that's really important, just to enable children to start primary school sort of with those skills that they need for learning.
Yeah. That's so interesting. I love it. Brain before behavior. So there's changes before it kind of the behavior has a chance to kind of catch up. So kind of touched on a little bit of individual differences there in terms of like autism and ADHD, but I guess babies' brains are all kind of very different, as we all are as humans. Are there any, would you say there's like any factors that influence that development, such as genetics, early experiences? You touched on it a little bit, or environment. Is there anything that, research shows that kind of like can affect that?
Right, so all of those things. It kind of goes back, I guess, to one of the things I mentioned very early on about how we sometimes just focus in on like a particular skill that we're measuring, and we kind of forget or don't pay as much attention to the context of this child that exists in this world. And so we know that there are important differences in brain and behavior development from children who are living in more deprived backgrounds. And so having that kind of socioeconomic gap is really substantial. And we know, so in education, we know that there is something like a 2-year gap from when the richest and the poorest child, even on that sort of first day of primary school, right? And that sort of gap in educational attainment continues throughout the sort of education that the child will go through. And that's really significant. And we can start to look at that already, right, in infancy and early childhood, to understand, okay, are these gaps driven by socioeconomic status evident like already from birth, or is it because of kind of factors that come with living in deprived homes, such as like access to resources, sort of differences in language quality, talked about kind of the role of the parent and sort of the way that they support children in their development by giving them opportunities and sort of demonstrating how to how to get through things. Those things are all going to be playing huge roles in these socioeconomic differences. So it's not just one thing that we can unpick, but we know that it is this significant factor. So I know that there's research that's being done actually comparing different cultures across different countries of the world. So kind of like a, UK based sample with samples in kind of rural Africa, and looking at differences in brain development of young children there. And it does seem like there's some really interesting findings. So this is the work out of the University of Cambridge with Sarah Lloyd Fox. She's kind of compared with FNIRS, the children's brain development in those two contexts. And there's lots of different intricate patterns that are different. And it'll be interesting to see kind of what happens with that research as those children get older.
Yeah, that's fascinating. So all kind of different, seems to be so many different kind of bits of research investigating all different parts, which makes sense. That's how research works.
Yeah.
um,
Um, just to add to like the cross cultural aspect of it, we had Frankie Fong on, who does research in Malaysia,
Oh,
children in Malaysia, Vanuatu, and New Zealand, and was talking about sort of imitation differences in slightly older kids. So I think it was not toddlers, 3 and higher up, I think, if I remember correctly, but sort of differences in how they perceive imitation and how they imitate people on screen versus in real life and things as well. Because yeah, that was very fascinating. So I wanted to just point that out. But yeah,
yeah,
sorry.
well, that reminds me of a study that my one of my colleagues has been involved in, comparing children in South Africa with children in Australia, looking at executive function skills in preschool children. And the results that came from there were kind of a little bit counterintuitive to what you might expect, because actually here they found that the preschool children in South Africa showed enhanced executive function skills, even though they were living in kind of deprived backgrounds, compared to the sort of children in Australia who were living in less deprived backgrounds. And that told a really interesting story, because it was actually suggesting that children in South Africa who were living in kind of more deprived areas are they have no choice but to use their executive function skills. They're almost kind of forced to develop them more quickly because of the demands of the environment. And one of the examples of that I still remember was about these preschool children having to catch this kind of transportation to the preschool. And those children were responsible for getting there on time by themselves. And so the researchers said she was testing with the children playing the games, and some of them were so concerned about when they had to go that they were kind of already thinking about that. And so some of those differences, I think, are impossible to ignore, and is something that research in this field in general needs to be more aware of, right? Because the results that I've talked about from my study are maybe true of the children that I tested in my sample in the UK, but may not be true in children in other populations across the world. So we need to make sure we're not sort of just having this biased perspective.
Yeah, that's completely fair. I think this might be a good time to, because we've gone on to lots of different types of research. If you had, I want you to pretend you've got unlimited funding. You've been given a £2 billion grant. The ethical committee are all on holiday for 2 weeks. So anything you want's going to go through. Please be sensible with that. What would be your absolute dream study to do?
I love this question, and I love the opportunity to kind of put all rules out the window. And that's kind of one of the things that came to my mind is, do you remember these kinds of programs that they used to show, where they, like Child of Our Time or something like that, where they would kind of follow these same group of children across their life, and they would look at them at all different ages when they're going off to school, and they would interview them. And I just think how much I would love to find a group of children around the world, right? When, meet their parents, sort of be able to film, their development, when they say their first words, when they're learning to inhibit, like all of these different things, and follow them literally throughout the course of their life, I think would be so fantastic. Just from the kind of case study perspective, right, of really understanding the different factors that happen in a person's life and how that might change their outcomes, but also having this connected group of children that are going through life at the same time, I think would be really exciting. And in terms of the kind of scientific outcomes from that, I think they would be invaluable, because we would be able to really understand, and it's maybe the fourth time I've talked about this now, but we would really be able to understand that holistic child's perspective and their experiences, that will help us understand, actually what has happened to the brain when a child lives in poverty, or what does happen to the brain when a child grows up in a bilingual household, or when they start school, and is that consistent, right, across the different cultures and experiences? So I think that would be incredibly exciting. It would involve lots of international travel, which would be great for me, not so great for the environment. But I just think that would be so cool. And I'd be there with my FNIRS kit in my backpack,
Amazing.
following them around.
Yeah, got the funding.
How big is an FNIRS kit, in just out of curiosity?
Yeah, so most recently, developments in the kind of technology for FNIRS have really taken off. Like, it is incredible now. When they were sort of first developed, it was rigged up to a thing on the ceiling with massive wires, and it was huge. But now it is literally something that can go into a backpack. So and I mean a child's backpack. So at Lancaster University, I'm part of the Infant and Child Development Lab, and there's a team here who are using a wireless FNIRS system, where the child will wear sort of the swimming cap, like I suggested. All of the wires are sort of short and self-contained on the cap, and then the sort of device is maybe a battery pack size, and it just goes in on a sort of child's backpack, and it's really lightweight, and they can just freely move around whilst their brain activity is being measured. So the technology now is just fantastic, and it allows us to do things like, if I were to travel around the world, these children could wear the kits in their backpack, right, as they go off to school, which is just fantastic. Huge kind of advancement in technology there that just is really
massive.
allowing us to ask questions we couldn't possibly have done before.
So we spoke about the dream research project. Coming a little bit back down to it, what are your what are your current research projects doing, and sort of like in your lab, and yeah, what's the future hold?
Yeah, back down to earth. So um, it's all about toddlerhood for me at the moment. Unsurprisingly, probably because of kind of where my research left off from my PhD. But what I'm hoping to do, and I've started doing some pilot work at Lancaster with this, is to invite toddlers into the lab to see if I can understand what's happening in their brains during executive function development tasks, such as the iPad task I mentioned before. And I'm doing a little bit of piloting at the moment with that, just to understand how the toddlers get on with the FNIRS system, and to see whether the task is still suitable, which it is. And what I'm hoping to do is to develop a longitudinal study across toddlerhood. So it might not be around the world and with all these amazing things, but in sort of the lab, I would love to see toddlers at sort of quite close together age ranges across this period, so I can really start to unpick. So here you asked earlier about like at what age would we expect inhibitory control to start really improving, and I think the answer is in that sort of toddlerhood period, so maybe from sort of like 18 months to 3. And so the research, I'm currently in kind of grant writing mode. Please fund me. I really want to work with toddlers and work with their families and try and find that missing puzzle piece, right, about how these executive function skills develop in kind of coherence with the brain during that period of time. And as part of that, I am developing some new kind of tasks that we hope to be able to use with FNIRS to give us a sort of more comprehensive picture of the other executive skills that are developing during that time.
No, I was just gonna say, get Beth on the funding board. She's already willing to give you 2 billion. So
Yes.
your
Well done. Yeah.
money will go
And you can be in
immediately.
charge of ethics too.
Yeah. Like you, Abby, you seem really trustworthy. I'm going to trust you.
Oh,
Okay. Um, I have one more question, which is, you said other executive functioning tasks. We mainly spoke about inhibitory control. What are the sort of other tasks we're talking about when what you're looking at?
yeah, good question. So, I mean, I guess we kind of focus on inhibitory control because that is where my research has focused so far, right? But executive functions is actually like this umbrella term. And under the umbrella sits kind of a number of cognitive skills. Typically in research, we focus on this kind of trio of skills, which are inhibitory control, but also working memory, and then cognitive flexibility or cognitive shifting. And so working memory is kind of our ability to hold information in our mind and do something with it. An example of this I think of often is kind of like a shopping list, a mental shopping list. Maybe you have 3 or 4 things on your shopping list, and as you put something in your basket, you then have to kind of update that information in your mind, right? Once you have the milk, you don't need to go and get it again. And then cognitive flexibility or cognitive shifting is about kind of having a sort of set of rules in your mind about how to approach a task or achieve a goal, but actually being able to adapt and be a bit flexible if something changes in your environment or if the rules of the task slightly change. So having that kind of flexible thinking. And you're probably already thinking, like, how on earth are you going to ask toddlers and babies to do those things, right? And it's similar difficulties as I spoke with before, but the way we've kind of approached it is to try and scale it back and think of, okay, what are the most simplistic versions of those skills that we could expect infants or toddlers to be able to do. So for working memory, one of the tasks that we've been working on with my supervisor is about kind of working with little kind of toy figures. So we present children with maybe 2 or 3 little figures, and then we do a little bit of sleight of hand, where one suddenly disappears inside a box, and we wait to see if the child kind of looks for that missing item, right? And we can kind of infer, well, if they look for it, they must have remembered that there was an additional one. And then for cognitive flexibility, I'm currently working on developing a task that is based on quite a famous task called the dimensional change card sort task, which is about kind of sorting things into either color or shape. And this task is commonly used to assess executive function in kind of older children, normally from sort of 3 years and up. But it involves quite a heavy language demand. You have to understand what you're being asked, whether you're sorting by color, whether you're sorting by shape. And if you don't have language abilities or ideas of what those categories mean, you're not going to be able to complete that task. So I'm working with some collaborators to kind of try and think of exciting ways to modify that task to be more suitable for toddlers. And one of the things I'm doing is instead of asking children to sort things like on a touchscreen or like flat cards, what I'm doing is kind of giving them physical objects to sort, and hoping that by giving them something tangible where they can physically see the matching colors and stuff, that it becomes a lot more accessible to them and means we might be able to assess flexibility a little bit earlier than we have done before. I don't know if this is going to work. It's one of the things I'm piloting at the moment, but I'm really excited to give it a go and to see what happens. And this, I guess, is part of experimental research, right? We don't know. We don't know what we're going to get, but it could be really important for the future.
The working memory task sounds so the one where you hide a figure sounds like the object permanent stuff which
Right.
they used to do, right? Um
Yes. So it
I
kind of is an extension of that,
yeah.
right? So object permanence is about whether an infant would, like, you're playing with a toy, it's hidden under a cloth or something. Is it that the infant actually searches for it and so they have representation that that object existed? Or is it that once it's covered and out of sight that there is just no representation of that object in infants' minds? And so we're working in late infancy, so we would expect that all children at that age would have object permanence around 10 months. And so we're kind of extending that a little bit. So instead of just hiding just working with one object, we've got maybe two or three objects to sort of see if they can remember how many objects to look for. That's kind of a paper that we've pre-printed and hope to be able to publish soon.
Yes. That's like so many different ways to like measure so many different parts of executive function and memory to a certain extent as well. I mean, I'm sure we could have probably chat for about 6 hours about all the different tasks that can be done.
Yes, it's it's fun.
And I guess how is it working kind of with that? Like obviously working with very young children. What's the most challenging part of doing that? Or do you find it's actually quite simple?
So I love it.
Mhm.
I enjoy working with families, working with babies and toddlers. However, it is certainly not simple. It is certainly not straightforward. And even if you think you have a good understanding of what you can expect from a toddler, they will do something that you had not considered. So they are unpredictable even when you try to predict them. And so I think one of the challenges that comes with working with this age group, besides kind of designing suitable tasks and getting them to wear FNIRS caps, is actually their kind of temperament on the day, right? So, and their sort of, how well regulated they are. So they could come having just had a really nice nap. They're really excited about being in a new place and they want to play the games with you and everything goes smoothly. But the next time they visit, maybe they didn't have a great nap, maybe they're hungry. You ask them to try and engage in a task and they refuse, or they just want to play with something else. And there's sort of no negotiating with a toddler, should we say, or it's very difficult to negotiate with a toddler. And so it's one of the things I think if you don't work in developmental psychology that might be very hard to appreciate, because if you have an adult coming to a testing session, most of the time they're going to follow the instructions, even if they're very bored. With toddlers, if they don't want to do something, they will say no, or they will leave the room. So, yeah.
I was like, mood. I feel that.
I wish I could do that, but
So you have to be flexible. You have to think on your feet a little bit and not care too much if things don't go exactly as you had imagined. Yeah.
Yeah, fair enough. Flipping it around, what's the most fun part of your research? What's the part of your research you've enjoyed the most?
So this question I could give you several different answers to. The first one, I think the most exciting one is, particularly in the longitudinal work I've done, right, is being able to share this with the same families across this period of time. And so the families come back again to the lab and you remember the children and the parents and you see how much they've grown and you're excited because you can then look at their data, right, and see like, wow, you know, this child is now able to do this. And having that connection with the families is really, really exciting. And then I think the second part for me is kind of unlocking these puzzle pieces. And I think I have a lot of puzzle pieces still to unlock, but just being able to kind of like start in my research to start to get some information that we didn't have before is really exciting to start to see, okay, like, yeah, now we know this, but we don't know that. So that's like, you know, starting to build up that jigsaw puzzle has been really exciting, especially as I'm quite a new researcher still. So I feel like I've got, lots to look forward to.
Not jaded yet.
Yeah, ask me again next year.
So I know we've kind of like probably touched on it in bits and parts, but I guess like it was good to just like nail this down. Like, what do you hope your research contributes to the field of developmental neuroscience as a whole?
Wow.
Yeah, no, it's a big one. Left it for
Big
the end.
question. That I hope that I'm contributing something new, and I think that I am. I think that I am contributing knowledge that the field, very specific knowledge that the field hasn't had in the way that we've been able to give it during this kind of research. And I hope that the kind of keep talking about jigsaw puzzles, but I hope that with these jigsaw puzzle pieces, when I keep finding these things from my results, are actually going to be able to translate into meaningful things for our families, right? I think I've said that kind of is my bigger kind of perspective. My bigger goal is to be able to do something that actually has meaning for the families that we're working with, for preschool educators and early years professionals. That actually means that we understand more about how these skills develop and how the brain supports that, so that we can then put into place strategies or supports that I'm really sorry, I've got my Teams on Do Not Disturb and it's now pinging. But yeah, I hope that I can kind of, I need to or we as a field need to understand what this development looks like before we can sort of offer strategies and support to parents. But that's my long-term goal, and I hope that's the impact that my research will have.
Excellent.
Fingers
That
crossed it
sounds
does.
very necessary. Okay, I will ask, have you got your hot take ready?
I have a couple of hot takes.
Yep. I'll ask you, Abby, what is your hot take?
Okay, so one of the things I've been thinking about as my hot take is that, and this sounds obvious, but children are the future. So a lot of research that maybe attracts attention or attracts funding is things about the future. So artificial intelligence and new technology advancements and amazing medical advancements. But I want to kind of share, and that my hot take is that children are the future. And it is the children that will go on to be working with artificial intelligence, or who will be the future doctors. And so investment in infants and early childhood is so essential because they are our future. And it's great that technology is moving us forward and we need that. But I think often children and education can be neglected in terms of priorities for government and funding. And I think we should kind of remember that the children, we're nothing without the children, right? That they are the future guardians of our world. And I think that's so important, that we kind of do what we can to understand child development and give children the best future possible.
Awesome. You said you had multiple. Do you have another as well?
So my second one was about the importance of the early years. So it's kind of like, what's that expression about, like drumming the same beat? I don't know. It's kind of the same thing, because a lot of research is done once children are in the primary school. And it's about putting in place interventions and support that enables children to perhaps make improvements in primary school. But my hot take is that Actually, that's quite late. And we work with infants and toddlers and early years professionals who would be able to tell you probably already which children in their nursery schools will need additional support. And so I'm banging the same drum again, that investment in infancy and early childhood is so important, because it's good. We have those early years are where the rapid brain development happens, from 0 to 5. That's 90% of our brain development happening. And so it's such a crucial time for intervention. And so actually, I think once the children are in the primary school, that's actually quite late. So that's my hot take. Controversial me.
Two great
Awesome.
hot takes. Like it. Children of the future.
Children are the future.
Uh, oh, well, I think we can kind of end there. Do you have any final things to say, Abby? Or do we end on children of the future?
Children are the future. But no, just to say thank you so much for inviting me. Thank you for this great conversation. And it's so fun to have the opportunity to talk about my research and my passion. So yeah, thanks so much.
I
You're welcome. It
enjoyed
was
it.
great
It's
to have
been-
you.
Yeah, it's been very enjoyable. Very enjoyable. A good chat. A good year,
Thanks.
as we say.
Awesome. And yeah, once again, thank you everybody if you're still here for listening. And yeah, thanks Beth for coming back on. Hopefully one more episode, and then the next time we talk to you, you'll be a doctor. So
Gosh, can
Yeah.
you imagine? Oh,
exciting.
it's going to be Dr. Bethany Facer. That's never go. That's. I'll only be introducing myself as that. Well, let's not get ahead of ourselves. I might fail. And that will be.
Come on.
hideous. No, that's not going to happen. No, it can't.
Okay,
Happen. No, it can't happen.
brilliant. On that positive note, thank you. Thank you again, Abby. Thanks everybody for listening, and until next time, take care.
Bye.
Bye.
Bye.